Okay, today we're going to discuss enhanced switching technology. So there are some switching features we're going to talk about today. So topics we're going to talk about VTP, which is VLAN trunking protocol, and STP. They are the switching features, switch like some advanced features. So what is VTP? VTP is a VLAN trunking protocol. VTP features consistent VLAN configurations across all switches in the network. VLAN tracking over mixed networks such as Ethernet to ATM, accurate tracking and monitoring of VLANs, dynamic reporting of added VLANs to all switches in the VTP domain, adding VLANs using plug and play. So how actually it works, let's have a look. So if you go to uh, my page, okay, just search for it. So let's say we have a switch in here and we have another switch and we have another switch, three different switches we have, and we have the internal connectivity, these switches like that. Now in VTP what it does, it's actually helping to configure the VLAN informations in multiple switches. So this is VTP, and normally in one switch we create VLAN. Let's say we have VLAN 10 and VLAN 20. Now if you want to configure this VLAN 10 and 20 in this switch, so what will happen, we have to again create VLAN 10 and VLAN 20. We have to create this VLAN manually, right? So that's the normal things we do, but benefits of the VTP that we can make one of the switch as a VTP mode servers, like VTP server. If we make VTP server, then other switch we make this one VTP client. Sorry,
What
client.
was the other protocol that did the same thing? I forgot again. I think it was day 3. There was another with server and the client.
Server client in relations to this STP or switches.
No. There was another switches. We did it on day 3, I think. There was another one that we set up. It was a server and a client for something. See, I should have studied, but I forgot what it was.
We have looked at NTP, even NTP.
No, not NTP, not at time. What's the other one?
We talked about access control list, OSPF, NAT, and yeah, RIP. Those kind of things we looked at in day 3.
Was it day 2? I'm pretty sure it was day 3. There's another
Okay.
DHCP. Hang on 1 second. DHCP server we set up.
Yes, DHCP. Yeah.
So yeah, must be day 2 then.
Yeah, DHCP, that's different stuff, but this is only happening with switches.
Okay.
So if we in this VTP environment, we can create a like a domain. Domain is kind of like an area, like we make one of the area. This is our kind of like company area, like that. Yes, this is our domain, and this domain we have named, like domain means a company name, like ABC. That's the domain name. ABC, this is the ABC company. This is the company name, kind of like that. So our domain name is ABC. So in this domain, we make this switch 1 as like VTP server, and switch 2 we make VTP client, and switch 3, if we make switch 3 as VTP client, then in this way from the VTP server switch, we'll be able to create, we'll be able to delete, we'll be able to rename, modify the VLAN informations, and those informations will replicate to switch 2 and switch 3. That's the client does. Client is just following the server. So if you create a VLAN 10 and 20, this information automatically it will replicate in here. In this way, VLAN management will be a lot of easier, and it will be consistent as well.
You
Like
normally set it up same server as DHCP and all that stuff. Would you like in practical world? Would you set it up on the same as
yes, this
OSPF?
is kind of like a management servers, or so you can configure the DHCP in here as well. So DHCP servers and many other services access control list you'll be able to create in here as well. So this particular scenario, this VTP, when you configure the VTP, you'll have a one switch will be VTP server and another switch will be VTP client. And if you create like VLAN 10 and 20 in here, those things will propagate to other switches. If you change the name in here, or if you create another VLAN, like for example VLAN 30, or you make any changes with the name, this information will be automatically it will propagate over there, such as in here VLAN 30 and oops, so it will be VLAN 30. So it will be consistent and it will be management will be a lot of easier. The way you create the services in here, the automatic these VLAN services will be there. After that, manually you need to add the interface to the VLAN. That's manually need to be done.
Okay, so it changes automatically, but then you have to assign IP for every VLAN on per computer per switch. Anyway,
Yes.
yes.
Manually, like you need to add the VLAN. That task will be manual. It will be joined to VLAN like device will be like that, but we can manually need to join. Yes.
Mhm.
But the main benefits with the VTP is like VLAN management. Like if you have a 10 different switches located in 10 different places in your company, you need to manage only server. You don't need to manage the client. And if anyone want to manage the services over there, they'll not be able to manage because this is the client. But when you manage this one, you need to have a administrative privileges, and then you'll be able to configure, manage, rename all the systems you'll be able to do in here. That's the benefit with VTP. So VTP has server and also client. This is the two majority of the mode we are using. We have another mode which is called transparent. For example, this one we can make, not this one, maybe we make another one. For example, this is another one, another switch. This switch we make as a transparent switch. Transparent means kind of like a neutral. Like if you create VLAN 10 and 20, it will not create VLAN 10 and 20 in here, right? So it will
Mhm.
kind of like, but it will be part of your um, network. Like it will, if you want to send something from here to there, kind of like that, the informations it will pass. Like VTP message, it will help you to transmit. That part it will do, but it will not participate your VTP domain. Okay,
Yep.
that's the benefit of but transparent, maybe this switch you're doing something else. Maybe you have some other stuff is connected with this switch, which you don't need to be part of the VTP. You're doing something else. So that's the transparent. And some older switches they have another mode called off. Off means they will not be able to participate, or they will not participate in your entire VTP VTP domain. That is the off. But majority of the switches you have like servers, client, and transparent. These three options available. But some older switches, they have like options VTP mode off. If it is off means it will not relay the informations, it will not participate, it will be kind of like a independent switch in your network.
Mhm.
So by default, all the switch will be default mode is VTP server. So this one we're going to look at and check. This is the VTP information. We're going to look at the configurations, how to make a VTP mode server, how to make a VTP mode client. We'll check those steps. This is the configurations. We're going to do the configurations as well. Initially, all the switch comes as like an independent server, but we need to make it VTP mode server or VTP mode client, and then VTP domain, Sydney or your company name should be there. VTP password, you need to put the password. So pretty much these three lines of configurations can help you to configure the VTP. If you want to check the VTP status in any switch, show VTP status.
Mhm.
That's the show command we need to know. Another thing, we have a VTP pruning. So what is VTP pruning? By default, if switch are connected in this way, switch main job is to pass the VLAN information. For example, this switch, you have one of the PC. So this PC you have is belongs to VLAN 3. So when this PC is sending some informations, it will go to another VLAN 3. So um, this switch should send this one to that switch because it has VLAN 3. But by default, switch characteristic is it will actually send the broadcast message to all other connected switch. So in this scenario, if you do not have any other configurations but basic VLAN configurations, this switch will send that VLAN traffic to this switch. This switch will send in here and here as well. But there's no VLAN 3, so this switch don't need to get this VLAN 3 informations or frame information. So we can configure pruning. If we configure the pruning, then this link will not send any VTP message. That's the benefit. In this way, only the switch is related to this VLAN 3. That switch will get the frame. So VTP pruning stops any unnecessary broadcast, multicast, and unknown unicast frames on a VLAN are forwarded over a trunk link only if the switch on the receiving end of the trunk has ports in that VLAN. So that's the main thing with VTP pruning. So if you have a large infrastructure, it's good to configure the VTP pruning. In this way, the network performance will be improved. So VTP we're going to configure and have look. So this is the two informations about VTP. Now we're going to talk about spanning tree protocol, which is STP. So spanning tree protocol, how it works. Where is our picture? Okay, this is, I'm going to open STP. Yeah. So we're going to talk about STP, spanning tree protocol. So how spanning tree protocol works? So STP, what it does is actually block the redundant link. Let's say you have a switch 1, switch 2, and switch 3, right? You have like 3 switches. And if this switch is connected in this way, like 1 link, 2 link, and 3 link, even this switch has multiple link. Now, in switch 3, we have a PC, PC3, and this PC want to send something to PC1. So now what will happen when you send the frame? It will go via this link. It has 3 options, these 2 links and these 3 links. By default, if STP is not enabled, all the frame will go via this 3 link, 1, 2, and 3. So problem is, many different way, all the frame will reach in this switch 1. So switch 1 MAC table, it will have lot of frames, unnecessary frame, because it needs only 1, it doesn't need 3, but it will send 3 because switch main job is forward the frame. Now if unnecessary frame came into this switch, then what will happen? So there will be lot of frames. Also MAC table will be full. This is also called broadcast storms. So eventually this switch database will be corrupted, or it will be very slow. Those things will happen. To avoid these situations, we have like a STP protocol. So STP protocol, what it does is actually stops the unnecessary um, uh, link. So how it stops? It does the election process, and with that, it's only keep only one path open, and other multiple or redundant path is actually blocked. So we're going to look at how STP select one of the switch as like a root switch and block all other redundant path. So by default, every switch you have 2 informations. One is MAC address, one is priority, right? Every switch will have MAC address and priority. Switch 1, MAC address and priority. Switch 2, MAC address and priority. Switch 3, we have MAC address and priority. So the switch, what it does when they are connected in this way, they does the election process. And the switch who has a lower MAC address, that switch, sorry, the switch who has a lower priority, that switch will be root switch. But in this case, which switch has a lower priority?
Neither.
Neither. So that means they are all same. So if it is all same, the switch who has a lower MAC address, that switch will be the root bridge. So which one has a lower MAC address based on this?
Which one?
Switch 1. So in this scenario, switch 1 will be the root bridge, right? If switch 1 is root bridge, then other 2 switch will be non-root bridge, non-root bridge. And when a switch is a root bridge, all the port will be designated port. So these 4 ports will be DP, designated port. DP means a forwarding port. And other switch, they must have to have a one root port. Root port means from that port it will send the traffic to the root bridge. So in this scenario, from switch 3 point of view, let's say we're going to talk about uh, this link later on. This switch has a fast Ethernet 01, this is one link, and fast Ethernet 02, this is another link, right? We have two link, but we're going to talk about fast Ethernet 02, that link later on. But now we're going to talk about fast Ethernet 01 for this one. Now from this switch 3, this is you have one link, and this is you have another link. By default, every link, if it is fast Ethernet or like gigabit Ethernet, this switch will have a cost. So cost is like a default STP cost is based on the link. For example, this is fast Ethernet. This is fast Ethernet link, cost is 19. This one is cost is 19. So if it is 100 meg, for example, 100 MP, cost equal to 19. If it is 1 GB, cost equal to 4. So that's how the STP default cost we calculate. Now so this link, assume that all the links they are fast Ethernet links. So from switch 3 to switch 1, this link cost is 19, right? But switch 3 to reach via switch 2 over there, cost is 19 plus 19 is 38, right? So from this switch 3, one link has to block. So which link will be blocked? This link, because this link is costly than the other one, right? So which link will be blocked? This one. From switch 3 point of view, this link is cheaper and this link is costly, so this link will be blocked. So which port will be blocked? Is it this one or that one? So that's also again based on the MAC address. So this switch port MAC address is lower, this port MAC address is higher, so this port will be blocked. And
So it's with the priority first and the MAC address, or
only MAC address.
Ports is only MAC.
Port is only MAC address, correct. And there are few other conditions in here. Every link you must have to have one DP. So if you have a one DP, so this link has to be DP, which is designated port, and this link has to be BP, blocking port, because of the higher MAC. And this switch point of view, to reach there, this switch has to be RP. What is a RP? RP is a forwarding port again, but RP from non-root bridge switch towards the root bridge. So this switch, another link, it will be RP, right?
Yep.
And in this way, this switch, it will have a RP. So that's how you can see that this switch has this port is RP, this port is BP. This port is DP, this one is RP. This one is a DP, and this one is a DP and DP. So DP, yeah. And all the end user automatically they will be DP, right?
Does this mean that it's only gonna be one link or two links coming out of the report at all times, or can there be more than one like root bridge, root port or designated port?
If you looked at this one, it has a 3 links, right?
Yeah, I mean, like, can there be more than 2 links that would have a DP and RP, or it will always be like one link?
One link.
One link.
One link, yes. Other link will be blocked.
Or what if it's load balancing? You can't have this configuration.
For that, we have a different solution that is called Ether channel.
Oh, yeah.
Ether channel we're going to discuss soon. But at first, STP, it has some, this is the STP basic characteristics. That's how it works.
Mm-hmm.
And in case, like, let's say this link is down, or sorry, this link is down, what will happen? Automatically, the other link, such as it is BP, it will turn to RP. So it will turn to RP. So if it is a RP, then this link, it will send the frame in here. This switch will send the frame over there, RP to DP. So if one link is down, still another link will work. Automatically, STP will organize that link to make it work. Yep. And in case if you have a 2 link like that, what will happen? Again, one link has to blocked, because otherwise it's the same thing. If switch is sending frame via 2 link, this switch will receive 2 frames, so which we don't want, so one link has to block. So which one will be blocked? The switch with the lower number, that will be open, and the switch which has the higher number, for example fast Ethernet 02, fast Ethernet 02, this one will be um, blocked. This side will be blocked because this is the root bridge. Root bridge switch port must be DP. Root bridge, all the port will be DP.
So once again, when does the higher port number get blocked? In which condition?
Higher port number. So if it is a multiple link, so one switch to another switch, if you have a multiple link, only on the time higher the switch port number, that switch will be blocked.
That's it. And when is the MAC address kick in?
In this case, because this is connected with the root bridge, so MAC address doesn't really matter because all the port has to be DP. So other side has to be BP, right?
Okay.
This is like because of root bridge. But if there's no root bridge issues, kind of like this one, then you're going to consider the MAC addresses.
Okay.
Cool. So that is like one of one of the things. And another thing we have like called BPDU message. What is BPDU message? BPDU is, let's say in Cisco there are many hello messages, many different scenarios. Cisco device, they send a hello message and also receive hello message. So BPDU message is pretty similar to like hello message. So what it does, every 2 seconds all the switch, they send the BPDU message to each other and they ensure that the link is okay, there's no loop in the link. So and also if any election process happen or any link is down, if one link is down, for example this link is down, then it will does the election process again. So that time like BPDU message actually discover is link is down or any election need to be there, all these stuffs. So BPDU is important, and BPDU stands for Bridge Protocol Data Unit. Every 2 seconds BPDU message is exchanged in between, right?
Yep.
So that's pretty much the STP discussions. Let's have a look few things from our slides. We can see that, yeah. So STP is a spanning tree protocol. Original STP was created to prevent loops. Switches send probes called bridge protocol data units to discover loops. If switch receives its own BPDU, loop exists. These probes also help select the core switch of the network called the root bridge. All switches find the best way to reach the root bridge, then blocked all redundant links. Bridge ID. So what is a bridge ID? Bridge ID is the name of the device in spanning tree. Bridge ID equal to priority plus MAC address. Default priority equal to 32,768.
How does that change?
Yeah, you can change it. We have the command. With that, we'll be able to change the priority. But
But by default, all switches come with that priority.
yes. But it's not actually true for all of the switches. It may some switches may have a different priority as well. But if you want to configure our entire network, we'll be able to manage this priority. We'll be able to configure from our side as well. So when we need to configure the priority, if you want to make a switch, the switch who has lower priority, that switch will be the root switch. So if you want to make a switch as a root switch, during that root switch, root bridge, they're the same thing. Many different places they actually named in different way, but they're actually same thing. So root bridge, if you want to make a switch as a root bridge, you need to lower the priority.
Since that looks like a multiple of 2, does it need to be the same way? Or
We can manage the priority in every switch. So
I
first
mean, like,
thing,
does the priority has to be in this format of
yes,
multiples of two?
yes, priority, we need to put some certain number over there, incremental value. For example, 4096, like that.
Yep.
So yeah, root bridge elections. If the switch has a lower priority, that switch will be the root bridge. But if same priority during that time, lower the MAC address, that switch will be root bridge. Older switch may have more chances to become root bridge because they may have a lower MAC addresses. That's why. This is like a default characteristic. If you do not configure and plugged in multiple switch together, during that time, one of the switch will be root bridge automatically. But we don't want that. That's why like we'll be able to configure the priority, and in this way we'll be able to make like one of the switches like a root bridge.
Hmm.
Spanning tree operations. So some code informations you need to know. One root bridge per broadcast domain. That means if you have a one VLAN, right? That will be one broadcast domain. So if you have a five VLAN in your network, you'll have a five root bridge. Five broadcast domain. So each broadcast domain will have a separate root bridge. One root port per non-root bridge. So that means non-root bridge switch must have to have a one port will be root port. One port will be root port, like that. One designated port per segment. So we can see that, yeah, we can see that, yeah, we can see that per link you have the one DP, right? One DP,
Hmm.
one DP. Every link you must have to have a one DP. Non-designated means block port. Non-designated ports are unused. This is the blocking port or non-designated port, the same thing. So port types in STP, three port types: root port, a root port to reach the root bridge; designated port, forwarding port, one per line; blocking non-designated port, a port which is blocked. This is the STP port elections. Which port is selected to block? The cost of the link is used to select the ports, such as 10 Mbps, its cost is 100, 100 Mbps is 19, 1 Gbps 4, 10 Gbps 2. They are the STP cost. Port elections. First, all ports on root bridge are designated port. Excuse me. So if we looked at here, there are multiple link in here. So this switch has a lower priority, sorry, lower MAC addresses, but all the switch has same priority. This switch will be the root switch, and this two port will be DP. This switch, one DP and one RP. RP will send the frame towards DP, and this switch, this side is like a higher MAC, that's why this port will be BP, and this switch has to be RP. It will send the traffic towards the main switch. Now port elections. In case of two switches, lowest port wins. This is the fast Ethernet 01 and fast Ethernet 02. There's a two link. So higher the link, that side it will be blocking port, and this will be open. Now this switch, let's have a look. So which one is the root switch? in this scenario?
Lowest MAC address, the bottom one.
Bottom one, right? Yes, and these two port will be
Designated ports.
designated port, right? And then in
That one will be the root port.
root port, and this one,
Um, Designated port.
and this one,
Uh, Root.
root. Let's see. This is the root port, correct? This one will be DP, this one will be RP, and this port
BP.
BP, because this cost is 100, right? So this is the root bridge. So all the other switch, they will find the shortest or cheaper path, and with that path they will send the frame. That is the main idea. So if this switch, even their closest link, but still cost is 100, so this switch will send the frame via the other switch, still it's cheaper cost, so that's how it will send the frame. Okay,
Mm-hmm.
so STP configurations show a spanning tree. So that's the command we can apply, and we can see the spanning tree informations, STP informations. And this command we can make with this command we can make a switch as like a root bridge. Command is spanning tree VLAN 1. You need to put the VLAN and then root primary, and this is one of the way we can make a switch as like a root switch straight away. Or if you want to manage the priority in your network, we can do that way as well. We can lower the priority. We can make a switch as a lower priority switch, and then we can make that one as a bridge. So we have both options available. This is STP port status, what they do, like blocking, listening, learning, and forwarding, and disable. There's a few different options we have. So we're going to look at during the configurations. So from turning from listening, learning, and forwarding, it takes about 30 seconds. For listening status, it takes about 15 seconds. Port, when it is learning status, it takes about 15 seconds as well. Forwarding, it takes time as well, altogether 30 seconds. So many PCs can boot faster than 30 seconds these days. So if something happened with switches, if they want to converged during that time, it may take a bit of time. So switch will lose the port connectivity. So we have one of the options which is called PortFast. With that PortFast, we can make one of the port as like a fast forwarding port. This is only applicable for the end user where there is a single host is connected. So let's have a look few configurations, then it will be easier. So I'm going to open packet tracer. So this is switch. You're going to take few switches, one switch, two, three switch, and we need redundant link. One link, two link, three link. So if it is connected like that, which switch actually switch 1, we have switch 2, switch 1, switch, okay, we make this one switch 2, this is we make switch 3, this is switch 3, right? So now which one is the root switch? We don't know, right? So if you click on the switch, go to CLI, enable show spanning tree. So that's how we can see what's going on. This is switch 3. I just changed the name to switch 3. So if we looked at switch 3, it has two interfaces. Both interface is designated port, right? And if we go up, you can see that this is the VLAN 1 informations, and this is the root ID. Root ID means root bridge information. This bridge is the root. Is saying
Is it
this
a
switch is the root.
priority per switch or per VLAN again?
We'll find out. Looks like they are all same priority, but now we'll check all of them, right? So priority 3000, sorry, 32,769, and priority is this one is same. Let's go to our switch 1, enable config T, first name, this is switch 1. Yeah, exit, show spanning tree. Again, this switch has the same priority, so it's basically they go with MAC address, right? We'll check the MAC address soon. Let's change the switch name, enable config T, host name switch 2, right? This is switch 2. Okay, now all the switch they have a same priority. The switch, which switch is the root bridge? This one. Priority is 0001. Let's say switch 3, switch 2. So if I do exit, show spanning tree, so 0060, right?
Yep.
Otherwise 001, this one, show spanning tree, 0001, C75E 7465. Oh, sorry, I'm looking at, this is the root bridge information, right? I need to look at the bridge ID. What is the bridge ID? The switch, own, priority, and MAC address. So this is 0001. This one bridge ID is 0060. This one bridge ID is 0060 7057 6383. So this one is, yeah, that is starting with 6. This is starting with 5. This is lower, right?
Mhm.
You following?
Yep.
So this one is, this switch has a lower MAC address. So that's why
But
this,
like in real world scenario, it's pretty much always goes by MAC address, yeah?
yes.
Or would you assign priority first? Or you just leave
Uh,
priority default most of the
so
time?
real life scenario like this is it's all automatically default is like MAC address. Now what I'll do, because I don't want this switch to be root switch. Now at the moment this is the root switch, right? So what I'll do, I'll just make this switch priority lower. So what I'll do, config T, spanning tree, spanning tree, VLAN 1 root primary, right? This is the command. If I may apply this command, I'll make this my switch 1 as like a root bridge. So this command, if I do show spanning tree, you can see the listening. Listening means now because port status is changing, so it's listening now. After that, learning. See the listening, learning is happening. So 15 seconds, 15 seconds. After that, it will be in Still learning. After that, after 15 seconds, it will be in forwarding state. And root bridge, now this bridge is the root. Now this one is the root bridge. So MAC address doesn't matter. So we change the priority, and priority you can see this is the lower priority. And now I think 15 seconds gone. Now both port, their designated port, forwarding port, cost is 90, right?
Yep.
So show spanning tree, we can see simply this is that's how it does the root bridge election process.
I just
Yeah.
gotta get used to quickly finding out which is designated, which is the root port. I just have to go over it again. Right now it's a bit like overwhelming. Just once I go over it, it'll be alright. I get how it's selected it. It's just like root port designated port. I sort of keep it like it doesn't click in automatically. It'll come with something.
But easiest way to remember, like when you make a switch as a root bridge, all the port will be DP.
Designated.
And after that, this switch has to have one RP.
Root port.
Root port, and this switch also has to have a one RP. And other link may be this link. Other link, the other port. Every link you must have to have one designated port.
Yep.
And other port has to be either RP or blocking port. So if you remember some conditions, you'll be able to find out the port link information. So this is the link we have, and now this is the cost. You can see and show spanning tree. This one is showing us root ID. So root ID is always bridge ID informations or bridge switch or root switch informations, and bridge ID is the local switch informations. Now we're going to look at in case if we connect another link from this switch to that switch, then what will happen? Now again, STP will do another election process. Let's check. Show spanning tree. This is switch 3. See, it's make as like an alternate blocking port. And this side, show spanning tree learning. Now forwarding, right? So root B side, all the port will be designated port, and this switch side, one will be blocking port. So this is like a default STP characteristic, so something has to block in here. But we can do one more thing in here. If it is a multiple link, we can configure the ether channel. So what is ether channel does? Yeah, so this is the STP configurations we are doing. This is our root bridge. So root bridge means all the traffic will send their frame towards the root bridge. If it is a wrong switch is becoming the root bridge, all the network traffic flow will go to the wrong switch, and that's how the network performance will be degraded. So now in case if you have a two link, we can actually bind the two link. This is called ether channel. Ether channel. So what is ether channel does? With that we can bind multiple link together. In this way, benefit is that still we'll have the redundant link, but the redundant link will not be blocked. So that's the benefits, and you'll get a cost will be lower. You'll get a high speed as well. So this switch we have a port number 3 and port number 2. This two port is port number 2. Just want to make sure 3. Yeah, 3 and 2. Yes. port number 3 and 2, and this side we can see that port number 3 and it must be port number 2. So these two port we can configure the ether channel. Config T interface FA02 channel group 1 mode on. This is the configurations. Channel group means we have to make a one port channel, and this is the number. We can put 1 2 3, any number we can put. And mode on means we are enabling this channel group 1.
Channel group is a command to enable ether channel.
Yes. Now this is 1, then I'm going to take port number 3.
How many ports can you put in?
Up to 8 port you can combine together and can create ether channel.
Can you have like 2 4-port ones?
Yeah, up to
Is
8
it only
port.
one ether channel per switch?
Yes, up to 8. Now at the moment currently we are doing 2 ports. You can do 2
I mean,
3.
can you have 2 ether channels, or it has to be only one per
No,
switch?
you can have 2. In one group you can have up to 8 interface. So you can, yes, you can configure multiple ether channel from one switch. Yes. For example, you can create another one in here, right?
Yep.
So you can do multiple. Yes, no problem. Now I'll go to this side. Config T interface FA02 channel group 1 mode on, right? Interface FA0/3, same thing, channel group 1 mode on. So now this both side I have configured. Now if I do show spanning tree, then I can check. See the PO1, that's a port channel 1. Listening and look at the cost is 9, right? It was 19 before.
Yep.
Learning. Okay. Switch 3, let's go to switch 1. Show spanning tree. Still cost is 9. And you can see this is a share. Type share, and this is like a point to point. This is kind of like a default priority. Now it's done. Yes, forwarding. See, now you have, like, this is the benefit is that you get now combined bandwidth, cost is lower, and there's no blocking port, right? Before we had a one port was blocked, now is not blocking port. So ether channel is very efficient. We can use the ether channel to configure this kind of link. And we have one command, show ether channel summary, right? This is the ether channel summary. It will tell you that this is the group number, this is the port channel is in use. P stands for in port channel.
Import channel means that's used in the ether channel.
Yes, port channel means ether channel. So there's a few things we have looked at in here. One is like, VTP and spanning tree protocol, and then ether channel. So these are the advanced features. They are related with switches. Oh, VTP. So how VTP functions? We'll have a look. Show VTP. Oops. Status. Oops. Show VTP status. So VTP status, you can see that this switch is a server, right? Every switch is actually by default, they are the server. Yeah. So show VTP status. This one also server. So what is the main benefit with the VTP? If we create a VLAN in here, this VLAN will automatically propagate over there, right?
How come it's called trunking protocol? Do we know
Because
we have to have trunk ports
yes,
or?
you need to have a trunk port as well. We'll see in this two switch
So you
how.
have to enable trunk ports for. Yeah.
Yes. So for example, switch 1, config T, oops, um, okay. At first interface FA0/1 switch port mode trunk. So I make this port as a trunk port. I'll go here, this switch port number 2, I'm going to make it trunk port. Interface FA0/2 switch port mode trunk. So now I have like two trunk port. So trunk port, what it does, it will send and receive the VLAN ID informations. That is the main benefit with the trunk port. Now this is my root bridge. I want to make this switch as like my VTP servers. So exit VTP domain. So I need to create a VTP domain ABC. This is just a name. Now VTP mode server.
Oh, so we did set up VTP before, just really quickly. That's right.
Yes, VTP we can set up anytime. Yeah, we can simply just put the VTP domain, VTP mode servers, VTP password. Just put Cisco. You can put any password you like. So these three informations is required. And after that, we go to switch, exit from here, VTP mode client, right? Um, VTP domain. At first, we need to say which domain we are talking about. VTP domain ABC. VTP mode. This one will be client. So you need a password. VTP password Cisco. So password has been set up. Now end show VTP status. We can see this is the client mode. So that means this is, we make it server and this is VTP client, right? So if we create a VLAN ID in here, automatically it will propagate over there. That's the benefits. Let's do it. Switch 1, I have created VLAN 10. Name sales. Exit VLAN 20. Name it IT. Now I got two VLAN, right? Show VLAN brief. We can see that we have now two VLAN. VLAN 10 and VLAN 20. Now if you go to this switch, show VTP status is a client, show VLAN brief. Look at that, right? Automatically sales and IT, that VLAN is active in here. So benefits is that the spelling, caps lock, small lock, and all these things, like if you make any changes in your server, it will reflect in client. That's the benefits.
No,
But
normally in switches you would disable VLAN 1, yeah?
by default, yes, you can change the native VLAN as well, or you can block the
How do you
default.
change the active VLAN? Or you just type in VLAN shut, VLAN 1 shut?
Config T, kind of like VLAN, yeah, shut. VLAN 1, like shut.
So
Sorry,
you
this
put
is
like
interface VLAN 1 shutdown, right? That's how you
yeah.
can put shut, or if you want to make it up, no shut. That's how you can do.
So if you shut it down, all the interfaces will be pretty much blocked off, and you have to manually assign one by one. It won't forward the packets in.
Yes, those port will be like under shutdown VLAN, so they will not perform any task. And you need to pick up one of the port and then put it in the working VLAN, and all other port will be off.
Mm-hmm.
But before that, you need to have your proper planning, like you need to, which one will be your management VLAN. You need to have a management VLAN, means that need to have an IP address so you can
Tell that to it.
tell it to it. Yes, correct.
Can you put passwords in the VLAN?
A VLAN, not really. You can't put the password, but in this VTP servers and client, if you can manage the VLAN only from the servers.
Okay, so once you put a password on the server, it'll still propagate it to the other ones. So there's
Correct.
no.
If you want to create VLAN 30, look at that.
Yeah,
VTP
I go.
VLAN configuration is not allowed when device is in client mode.
Yep.
You can do that. All good.
Yep.
So there's a one more things need to check, which is called RSTP. This is also related with RSTP. RSTP stands for Rapid Spanning Tree Protocol. So STP convergence time is around 50 seconds. Write down in here. STP convergence time is roughly around 50 seconds, right? Convergence means how quickly a port turning to a different port. That is the convergence time. But RSTP is faster. RSTP is a rapid spanning tree protocol. This is called 8021W. That is the standard. That's the standard. And STP standard is 8021 8021D. That is the standard. So RSTP main thing is faster convergence time. So many modern switch, they may have like RSTP configurations, but you may have some old switch, they may have STP configurations. But switch, either all the switch will have STP, or if you want to configure RSTP, all the switch has to be RSTP. So if I go here, this switch 2, just to check it out, show spanning tree, you can see spanning tree protocol enabled IEEE. That is like a normal STP. So all the switch, they have a show spanning tree. All the switch, they have IEEE. But what we can do, we can make this switch as like a fast forwarding switch, right?
Mm-hmm.
How to do that? Config T spanning tree.
Do you put a fast forwarding switch normally on the bridge?
No, there's no specific password for that each of the protocol. But because if you logged into the switch before that, you already put the password, right? Enable password, um, basic password, enable password, all this password you put, then you logged into the switches, right? After
Yep.
that, you configure the spanning tree stuffs.
You'd normally put everything in the rapid, yeah?
Yeah. So spanning tree, uh, pro, no, not spanning port first. Spanning tree mode rapid PBSD. Okay. Spanning tree mode rapid PBSD. This command will enable a switch as like a RSTP. So if after that show spanning tree, we'll be able to see that this is the RSTP, right? That's how we make the RSTP. So if we go here, this switch is still IEEE, so we're going to configure RSTP.
Oh, so you have to configure RSTP per switch. You won't propagate like VLANs.
Correct, yeah. Spanning tree mode rapid PBST. Then this one config T spanning tree mode rapid PBST, right? So all the switches now got the RSTP. So why you configure the RSTP? RSTP, STP, the main difference is like RSTP is a newer versions of protocol. What it does is actually converts quickly, faster.
How many seconds?
There's no specific time frame for that, but roughly around 10 seconds. So it's faster. So this is the RSTP configurations, right?
Mhm.
Cool. So there are one more thing related with this STP, right? Each of the port we have looked at previously. If you do exit from here, show spanning tree protocol, we can see that this protocol it has a designated port DP switch. Okay, one of the port is DP. Why is one port? It should have a two port. Show spanning tree. Oh, okay. One port is blocked, one port is root port. So spanning tree enable RSTP. This is for VLAN 1. So you're looking at VLAN 1, VLAN 10, and VLAN 20. So each of the VLAN, they have their own spanning tree protocol and own root bridge. But in our case, we are looking at VLAN 1. So VLAN 1, it has a root port and also it has some alternate port as well.
So you have to get the interface VLAN 1 before enabling RSTP.
No, RSTP you can simply enable in global configurations mode for the entire switch. So another thing we have called BPDU. BPDU, Bridge Protocol Data Unit. So every 2 seconds, all the switch they communicate via BPDU message. So what it does? So BPDU message is only required switch to switch connectivity, right? If you have a PC, for example, I have a Endeavor device is connected in here. So this one is, it doesn't need any BPDU message because BPDU message is only related with switch. Switch is required that. But this port automatically switches a lot of empty ports, and this port, all the port, the BPDU message is by default enabled, right?
Mhm.
So which is not required because problem is if someone plugged in a ROG switch in here and then connect that switch with your this switch and then make this one as like a lower priority switch, then what will happen, this switch will be root switch and all the traffic flow will go that way. So which we don't want, right?
Mm-hmm.
Because this is a malicious switch. Somebody put in and change the priority and becoming root bridge, and then we'll have a big problem in our network. So to avoid these stuffs, what we do, we take port, for example, config t interface range fa 0/5 to 10. For example, these 5 ports we are not using for any of the switch connectivity, so we can make all the switch ports as like a BPDU guard we can put over there. So it will be spanning tree BPDU guard enabled, right?
Mm-hmm.
And also this 5 port, there's no you cannot enable this BPDU guard in the switch to switch connectivity. Normally where there is a port is empty, nothing is connected, or end user port is connected, you can enable the BPDU guard over there. Now in our case we have another another thing called PortFast. PortFast make a port as a fast forwarding port for end user. So same port we can put spanning tree PortFast, and you can see straight away you get the notifications. PortFast should only be enabled on ports connected to a single host. So connecting hubs, concentrators, switches, bridges, etc. to this interface when PortFast is enabled can cause temporary bridging loops. Used with caution. PortFast will be configured in 6 interfaces due to the range command, but will only have effect when the interfaces are in a non-trunking mode. So this is only we can enable for the end user connectivity, right?
Yep.
So that's pretty much the discussions about our STP.
Pretty straightforward.